Imagine looking up at the night sky and seeing a meteorite hurtling towards Earth. Wouldn't that be scary? While the chances are slim, the threat of a large meteorite crashing into our planet is a spooky reality. These near-Earth objects, lurking in the vastness of space, could bring catastrophic consequences. But how real is the danger? Are we living on borrowed time, waiting for an astronomical disaster? The universe around Earth is a huge field peppered with countless stars, some of which sometimes wander dangerously near to Earth. These objects, which include asteroids and comets, orbit the Sun just as Earth does. However, their paths sometimes intersect with our planet's journey around the Sun, drawing them closer to us. This proximity, while often harmless, can sometimes pose a threat to Earth due to the potential for impact. One notable near-Earth orbit, NEO, is asteroid Bennu, identified in 1999. Bennu has become a subject of interest due to its projected close approach to Earth in the next century and a half. While the odds of an impact are low, at about 1 in 2,700, the possibility cannot be completely disregarded. This concern has led to proactive measures such as NASA's OSIRIS-REx mission. Launched in 2016, this spacecraft aims to study Bennu closely, even collecting surface samples to return to Earth for analysis. The mission's goal is to get insight into the formation of our solar system and to understand better how to potentially deflect or manage such NEOs in the future. The threat posed by NEOs is not mere speculation. Earth's history provides concrete examples of the impact of these celestial bodies. The most significant of these was the Chicxulub impactor, believed to have caused the mass extinction of the dinosaurs. More recently, in 2013, a meteorite exploded over Chelyabinsk, Russia. While significantly smaller than the Chicxulub impactor, it still caused considerable damage and injuries, underscoring the potential risks even from smaller NEOs. NEOs are classified based on their orbits and proximity to Earth. The Apollo group, for instance, includes asteroids like Bennu, whose orbits cross Earth's path. Other groups, such as the Aten and Amor asteroids, have orbits that are either mostly within Earth's orbit or lie between Earth and Mars. This classification helps astronomers monitor and predict the movements of these objects more effectively. The study and tracking of NEOs have advanced significantly with modern technology. Telescopes and space missions have become more sophisticated, allowing for better detection and tracking of these objects. This vigilance is crucial as it provides valuable lead time to prepare for a potential impact event. In some cases, it might even allow for interventions, such as diverting the object's path away from Earth. However, the majority of NEOs pose no immediate danger. Most of these objects, when they do enter Earth's atmosphere, are small enough to burn up upon entry, appearing as harmless shooting stars. Larger objects, capable of causing significant damage, are much rarer and are the primary focus of ongoing monitoring efforts. The study of NEOs is not just about averting potential disasters. These objects are also a scientific interest as they hold clues to the history of our solar system. The composition of asteroids and comets can reveal information about the early solar system, offering insights into how planets formed and evolved. The Century Risk Table plays a pivotal role in identifying and prioritizing potential threats from NEOs. This system constantly updates its risk assessment based on new observational data, helping scientists to keep a close eye on objects that could pose a danger to Earth. The history of asteroid impacts on Earth underscores the importance of this work. The Chicxulub crater, linked to the mass extinction event that wiped out the dinosaurs, is an unsettling reminder of the devastating power of these celestial objects. Other significant impacts in Earth's history, such as the Vredefort crater, further highlight the potential for catastrophic events. The Tunguska explosion of 1908 and the Chelyabinsk event of 2013 are more recent examples of the damage even smaller NEOs can inflict. These events, while not direct impacts, cause considerable destruction due to the intense energy released during airbursts. They serve as a warning of what could happen if a larger object were to strike Earth directly. In addition to the Century Risk Table, scientists utilize the Palermo scale to assess the risk posed by NEOs. This scale takes into account both the probability of impact and the potential energy release, providing a more comprehensive picture of the potential danger. As of now, there are over 100 known impact craters on Earth, each telling a story of a past collision. While most NEOs are small and burn up in the atmosphere, the potential for a larger, more destructive impact remains a serious concern. According to scientific estimates, global environmental catastrophes capable of causing widespread damage or even mass extinctions occur several times per million years. This reality underscores the importance of continued vigilance and advancement in space technology. Programs like NASA's Planetary Defense Coordination Office are dedicated to detecting, tracking, and characterizing NEOs. These efforts are not only crucial for planetary defense, but also contribute significantly to our understanding of the universe. Before moving on to what the future holds for giant asteroids hitting Earth, subscribe to our channel to know more about space and what lies in the dark. Hit the bell icon so you never miss any videos. When it comes to the chance of a giant asteroid hitting Earth, it's pretty slim, but it's not zero. NASA has been tracking about 90% of the near-Earth asteroids that are at least a half-mile wide. None of these big guys seem likely to crash into us anytime soon. There could still be some huge asteroids out there that NASA hasn't spotted yet. If a mile-wide asteroid smashed into Earth at a blistering speed of 30,000 miles per hour, the impact would be like a mega explosion, around 1 million megatons of energy. If an asteroid the size of a house hits us at the same speed, its impact would be similar to the bomb dropped on Hiroshima, about 20 kilotons of force. This would wreak havoc, flattening concrete buildings within a half-mile of the impact and wooden structures even further. In short, it would devastate any city. Now, if the asteroid were as big as a 20-story building, the damage would be even more catastrophic. The impact will be equal to the largest nuclear bombs today, about 25 to 50 megatons. This monster could flatten concrete buildings 5 miles from ground zero, effectively obliterating most major cities in the US. For an asteroid to threaten life on a global scale, it would need to be massive, like 7 to 8 miles wide. Its impact would stir up enough dust and ash to cover the whole planet, block out the sun, and spike temperatures at the crash site. This scenario would be apocalyptic, with billions dying and much of Earth's life wiped out. But even then, scientists think some life forms would survive. It would take a colossal asteroid, about 60 miles wide, to extinguish life from Earth. So what's the future look like? There is always a chance, however small, of a catastrophic impact happening again, way down the line. Some people, especially those who follow biblical prophecy, link this to the end times described in Revelations 8. But for now, there's no immediate worry. NASA and other agencies keep a close eye on these NEOs. If a dangerous one pops up, maybe coming from the sun's direction, it'll likely be spotted early, especially if it's big. And if we do spot a threat, we've got plans to try and change its course or even breaking it up with something like a nuclear bomb. Speaking of redirecting asteroids, NASA's already made history with the Double Asteroid Redirection Test, or DART. This mission, launched in 2021, successfully altered the orbit of a small asteroid named Dimorphos in September 2022. It was a first-of-its-kind achievement, showing we can indeed change the trajectory of a celestial body. Now, when it comes to asteroid hits, Earth doesn't see them that often. In the 20th and 21st centuries combined, we've observed only about 18 asteroid impacts. There are probably more that were either too small or just went unnoticed. Looking ahead, there's this asteroid called Apophis. Discovered in 2004, scientists estimate it has 1 in 100,000 chance of hitting Earth in 2068. So while the odds are low, the possibility is still out there, lurking in the vastness of space. Do you think Earth will ever face another mass extinction? Do tell us in the comments. Stay tuned.